Let's connect it all together. Now I'm on page 63 and I'm looking at how I'm going to connect this relationship together on a graph. Okay, so on page 63 it says you're familiar with the proportional relationships that start with 0, 0. When we plot our point, our 0, 0 is down here. For example, 0 hours worked means $0 earned. The problem on the previous page does not include 0, 0. The problem states that there are already 2 inches of snow on the ground at 0 hours. This function starts at 0, 2. So our initial value, or our starting output value, is 2. So let's look at the graph on this function. I have 0 is my x, 2 is my y. So my time, again, is my x, and my y is my depth of snow. Coordinates for 0 hours, we have 2. At 1 hour, I have 3.5. Plot my points, 0, 2. Then I plot my point for 1 hour. I have 3.5. 2 hours. At 2 hours, I have 5 inches. So I move towards where the 2 lines meet. So at my 2 hours, my line shoots up this way. My 5 hours, my line shoots horizontally this way. And my lines both meet here. So let's do 3 hours. I have 6.5 inches of snow. So my coordinate is 3, 6.5. And I plot my point at my 3 hours and at my 6.5 hours. At 4 hours, I have 8 inches. So I'm going to put my coordinate, my x is 4 because it's this top row, and then my y is 8. It's my bottom row. Okay, so my input is my x, my output is my y. Then I'm going to plot at 4 hours, I get 8 inches. I plot my point at my 4 on my x-axis and my 8 on my y-axis. My y is always going to be our numbers on the right side in our coordinates. Our x is always going to be on the left side of our coordinates. So let's take a look at 5 hours. At 5 hours, the depth of snow is 9.5 inches. So I'm going to plot my point in my x, and then I start over in my y at 9.5. 9.5 is between 9 and 10. It's the halfway point. So this is where I will plot my point. This graph also shows the rate of change. Our x values and y values change at different rates, but the ratios of these rate changes is also the same. So let's take a look at our horizontal change, okay? Horizontal means that I'm going from left to right. I'm looking at my x-axis, okay? As you can see, at 0 hours, my change happens every 1 hour. So my horizontal change, 1 unit, meaning every unit that I move, there's a plot on that unit. It's 1 unit. Our initial output, again, is right here where our first plot is, and it's at 2. And then our vertical change from our initial output to the next plot on our y-axis. X values for this problem and our y values change at different rates, but the ratios of these changes is always the same. So from point to point, the values of y change by 1.5 units. So from here, our initial output, to here, our vertical change is 1.5 units. Our x values change by 1 unit. So from here, 0 to 1, where our next plot is, it is 1 unit. And looking at where our initial output is and where the line for our next plot is going to be equals 1 unit. And from where our initial output is on this 2 on our y-axis to the 3.5 on our y-axis, our vertical change is 1.5 units. That means our rate of change, meaning I'm going to divide my number by another unit, is going to be 1.5. 1.5 divided by 1 equals 1.5. So we're going to discover a little bit later on in this lesson that functions can have many different initial values and rates of change.